So the second type of polymerization reactions are what we call condensation polymers or condensation polymerization. And what that means is it's the same idea. You got two or more monomers that combine to create and produce a large organic molecule, or what we would say a polymer. But here, this will refer to monomers that are bifunctional. And what that means is that they contain two or more functional groups. So it could be two alcohols, two carboxylic acids, two ketones, etc., etc. So we have a bifunctional monomer that reacts with another bifunctional monomer. And we call them condensation because H2O is always produced. So the first example of a condensation polymer is going to be what we call a polyesterification reaction. And I'm going to underline the word ester because really it's synthesizing a polymer that is full of esters. And so the question is, how do you make an ester? Right? If we go back and review, we'd see that an ester is a combination of an alcohol and a carboxylic acid. But when it comes to condensation polymers, it has to be bifunctional. So we've got to have at least two alcohols and two carboxylic acids in each of the monomers present. So I'll do an example here. Let's say we have this compound. And we're going to react it with a carboxylic acid that is bifunctional. So when we look at each of these monomers, we can see that they're both bifunctional. There's two alcohol heads over here, and there's two carboxylic acid heads over here. Now the way this works is it's going to react one at a time. Now the OH, just like in ester reactions, the OH of the carboxylic acid is going to react with the H. And what that does is that together will make water. Then that leaves an available bond for our oxygen and an available bond for the carbon over here. And like our ester reactions, they're going to link at the carbon. So when we draw this compound, and we'll draw it over here, it's going to look a little different. You'll have your alcohol still in place because there's only one that occurred at a time. We'd have your oxygen over here, and it would be bonded to the carbon that has a double bond to it from here. And it's going to be 1, 2, 3. And your other hydroxide head and your carboxylic acid head, I should say, is still there. Like our polymers, though, we're going to put a bracket around. Okay. Now again, some questions go like this. They put lines, dot, dot, line, dot, dot, dot instead of the bracket. The meaning is the same. They're just trying to show you that it repeats. And this is important because you see, with each group remaining, right, with each part of the molecule still having, let's say, a carboxylic acid or an alcohol, that allows the reactions to continue because this carboxylic acid could react again with an alcohol. And this alcohol could also react with another carboxylic acid, and that's what keeps this process going. Now, the thing is, though, is that we said H2O is also produced. So we got our polymer here. Here's our polyester, and we don't have to know how to name these, not in Chem 30 anyway. And then our water that is produced. Now let's look at our second example. Just like our previous, the HO or the OH from the carboxylic acid is going to react with the H2O, making water. Okay. And each of these, when you look, they have a bifunctional group. This one has 2 alcohols, and this one has 2 carboxylic acids, so they are bifunctional, which fulfills the requirements for this to be classified as a condensation reaction. Now, it does have a branch, right? We could see that over there, that there's a branch over here. That branch is going to stay put, however, because the only part that is reacting are the H and the OH. So we're going to leave everything else the same. We have the O over here. Whoops. Okay. And that O, because now that it has an available bond, just like it did in the previous questions, here and here, they're going to bond at this point. And so we're going to, in a different color, show that bond. Our carbon will be over here. Okay, and it's going to keep all of its attributes in the sense that it has the carboxylic acid head over here. But, okay, at this part of the alcohol, we have to also keep the benzene. Okay, sorry, my cat came in here. So we have to keep the benzene. I know, buddy, I'm coming. Relax. Relax. I don't know if you guys can hear that meowing. And so we're going to put brackets around here to let us know that it repeats. Each one still has a carboxylic acid chain. And then, of course, since it did produce water up here in the green, we're going to make sure that we write water being produced, so that's plus H2O. And this is going to be the same again and again and again. Now in our final example over here, you could have something that looks like this. This is an unknown functional group to you guys, but I've seen it sometimes on diploma questions. This is what we call an amide. Okay, and the idea still holds true. If I were to put this on a test, I would want you guys to understand that, look, it's bifunctional, right? Each one is bifunctional. This has 2 carboxylic acid heads on the carbon parent chain here, and this one has 2 amides. So the same would still happen. You'd have the OH from the carboxylic acid that's going to react with the hydrogen from the amine on this side, and that would make water, and they would bond. There would be an available bond over here at this carbon site and an available bond over here at the nitrogen site, and they would be bonded over here in the same way, and you would still have water produced. That does it for condensation polymers, and that does it for Chem 30 in total. Please look over these examples again and the addition polymers and do the practice worksheets. Your test, right, is on the 22nd. It's on the Monday. So please do the problems, ask for help, and if the test does bring you down, then it does bring you down. Okay, but inshallah, that doesn't have to be the case. I'm open for tutorials starting tomorrow, inshallah. Assalamu alaikum.